All right, welcome to Math with Mr. P. Today we're doing 7th grade math, chapter 5, lesson 3. We're talking about properties of operations. We are going to be going over a lot of vocab today. But luckily that is our main focus today, is just the vocabulary. So we're going to skip down until we get to those concepts. Today we're dealing with commutative property and associative property. So these properties state very different things, but these two are the most alike out of the properties that we're going to learn today. The commutative property states that the order in which numbers are added or multiplied does not change the sum or product. So let's go to our digital whiteboard for an example. If I do 1 plus 2 plus 3, and for some reason things are not registering, there we go, this will be 6. No matter which way I do this, 1 plus 2 is 3, plus 3 is 6. Now, if I switch up some of these numbers, it will still be 6. So if I do 3 plus 2 plus 1, 3 plus 2 is 5, plus 1 is still 6. The order in which I add these up does not matter. The same can be said for multiplication. We're going to use the exact same numbers. 1 times 2 times 3, and this is one of those rare cases where it will still equal what it did if I added them all. 1 times 2 is 2, times 3 is 6. 3 times 2 is 6, times 1 is still 6. 2 times 1 times 3 will still equal 6. So the order in which we add or multiply does not matter. It will not change the outcome. For addition, it is known as the sum. It will not change the sum. In multiplication, it will not change the product. The associative property is basically the same thing, but now it's talking about how we group them. The associative property will deal with something like this. 1 plus 2 plus 3, but they're telling us that we must do 2 plus 3 first. This will still be 6. This means do 2 plus 3, which is 5. If the pen stroke will register, plus 1 equals 6. And the same thing can be said for multiplication. We're going to use something different. Let's do 2 times 3 times 4 this time. So no matter which way I group it, it will still equal the same thing. 2 times 3 equaling 6 times 4, which will be 24. And if I had grouped it a different way, let's say I said we need to do 3 times 4 first, which would be 12, times 2 would be 24. It would still be the same thing. So again, the commutative property deals with the order in which we add or multiply does not matter. The associative property is building off of the commutative property, but it is also grouping 2 out of the 3 concepts or terms. And so therefore, the order in which we group those terms when it comes to adding and multiplying does not matter. And that would be the associative property. Here are a few other terms that we must know. Number 1, a property is a statement that is true for any number. The following properties are also true for any numbers. So again, a property means that anything that we're saying about a certain number is true. So again, the commutative property states that the order in which we add or multiply doesn't matter. It's true. If I said the commutative property applies to subtraction, so say I say 1 minus 2 minus 3 is the same thing as 3 minus 2 minus 1. The order in which we subtract does not matter. Let's do the bottom one. 3 minus 2 would be 1, minus 1 would be 0. 1 minus 2 would be negative 2, minus 3 would be negative 5. These are two completely different answers. Therefore, that property is not true. A property is a statement about numbers that is true. The commutative property, the order in which we subtract, does matter. So this is not true. Therefore, all of these properties that we're talking about today will have true statements. The additive identity property, which states that when a number is added to 0, it is the sum of that number. So if I take 17 plus 0, my answer is still just that number. Basically, if you add 0 to any number, it is still that number. That is the additive identity property. The multiplicative identity property is when you take any number and you multiply it by 1, it's still that number. Using 17 as an example, if I multiply this by 1, it's still just 17. So basically the same kind of property, only one is adding 0 and the other one is multiplying by 1. And then the multiplicative property of 0 is any number that is multiplied by 0, it becomes 0. So if I do 17 times 0, my answer will be 0. Any number times 0 will always equal 0. Therefore, you have 5 properties that you have just learned. And here are some examples and symbols to go off of. And these should all be in your notes. Here are some examples. Name the property shown by the statement. 2 times 5 times n in parentheses equals 2 times 5 in parentheses times n. This would be an example of the associative property of multiplication because the order in which we group doesn't matter. They added of multiplication at the end. If you said just associative property, that would be fine. Examples here. 42 plus x plus y equals 42 plus y plus x. This would be an example of the commutative property. The order in which we add the terms does not matter. 42 plus x plus y, and then over here we have 42 plus y plus x. The order doesn't matter. None of them are grouped, so it's not associative. Therefore, this is our commutative property. 3x plus 0 equals 3x. Remember, any number that is added by 0 or added to 0 is still that number. We can go up. That would be the additive identity property. When 0 is added to any number, the sum is still that number. So 3x plus 0 still equals 3x. That is the additive identity property. Our last vocab term for the lesson is counterexample. So if we are going to state a property is something and it's wrong, so example down here, division of whole numbers is commutative, meaning the way which we divide does not matter. So their example is that 15 divided by 3, which is 5 by the way, is the same thing as 3 divided by 15, which does not equal 5. It actually equals 3 over 15. 3 divided by 15, if I divide both of these by 3, it will be 1/5. Therefore, the statement that division is commutative, meaning the order in which we divide numbers doesn't matter, is false. It is wrong. So if we're going to prove them wrong, we use a counterexample that shows why it's not. So basically what we did here is a counterexample. We showed that 15 divided by 3 equals 5. We did the work, and then over here 3 divided by 15 does not equal 5. We said that it equaled 3 over 15. It would be a fraction. Simplified it down by dividing both by 3, since that is a common factor, which would give us 1/5. Therefore 3 divided by 15 is 1/5. 15 divided by 3 is 5. These are not equal. Therefore, that is not a true statement. The conjecture that they use saying the property saying that division is commutative is false, and this right here is our counterexample. It's when we take their claim and prove it as false using math to show our point. And that is it for lesson 3. Any questions, comments, concerns? You guys know the routine. This is Mr. P. Thank you guys for watching.